Polynomials. Read together. 1, 2, 3. I can multiply polynomials. So we're done with all the addition and subtraction. Before that, we did exponential expressions, and we did multiplication properties, division properties, yes? Today, we're going to be combining all of those ideas. So some of your brains are going to go into, like, short circuit, so be patient. I'm going to go slow, then we're going to accelerate as we go, and kind of like the melody. Bam! So we don't need a fair amount because we already know what polynomials are. Is that correct? We wrote steps already for addition of polynomials, but I included distribution in there so that we can be one step ahead. So we don't need steps. You don't need to copy these. You already have these, okay? So step 1 is to distribute, which means multiply the factors into each inside of the terms of the parentheses using the multiplication properties of exponents. We know how to do that. Identify like terms. Did we do that? Yes. Do we know how to use commutative and associative properties? Yes. And at the end, simplify. Okay? So, just a reminder, when we multiply, what happens if they have the same base? We add. Everybody with me? All right. So, example Q. Copy this one, please, and write multiply, and then we got 2 parentheses x. All right, so I'm going to do this one first, and there's 3 ways that I want to introduce this. The first way is using tiles. Remember last week that we used tiles to show some of the polynomials, addition of polynomials, remember that? So look at this one. What's inside of the parentheses? X. So tell your neighbor what kind of tile that is. Tell your neighbor what kind of tile and what color. Okay, I heard rectangle, is that correct? What color? Green. Yeah, there are no blue rectangles. The rectangle was green, so there it is. But how many times does it say here to do that? 2. So check this out. That's 2 of them. All right? So watch. Therefore, do you have any 0 pairs here that we can eliminate some tiles? No. 0 pairs is when one is negative, which is red, and one is positive, which is green. Since we don't, what do you see here? 2x. Copy that and just draw a little rectangle. If you have green color, fill it in with green. It doesn't have to be that big, just big enough so you know it's a rectangle. And that's using tiles. The second way I'm going to introduce this multiplication is using distributive property. 2 parentheses x, close parentheses. Now this is what I want from you. In order for me to know that you're actually distributing, I want you to be really sarcastic with your multiplication. In the past, you just used to like underline or circle, whatever the case. Now I want you to show with an arrow like this. Watch. First of all, what is the coefficient of x? 1. So therefore, this is what I want to see. Circle this, arrow, and what is 2 times 1x? 2x. That's what I want to see when we're using distributive property. Copy that, please. And the last method that we're going to use is the area model. And this one, get familiar with it because you are going to be using it plenty. So, area model. How does that work? Well, if they give us 2 times x, we need to draw a rectangle. And it's not going to be like this for tiles. It's just a regular rectangle. And we're going to find the area of this rectangle. What is the side measurement? It's 2. What is the length? X. And how do we find the area? Length times width, which is 2x. And that's how we use the area model. Fairly simple? And we've seen all of them already. Did I show you tiles already the other day? Yes. Do we know how to use distributive property? Yes. And now the area model? Yes. Are we there so far? So I'm going to give you one for you to do by yourself, all 3 methods, and see if you can remember what tile to use. Here we go. There it is. 3 times negative x squared. I want you to show me all three methods. Go. All right, let's see. First, using tiles. Who remember that these tiles are squares, and what color? Red. Therefore, we have a red tile, but it says to repeat it how many times? 3. So 1, 2, 3. Kind of, sort of, yeah. And I heard somebody say they're rectangles. Of course, squares are rectangles. Definition of a rectangle is that they have parallel sides and 4 right angles. That just happened. That just happened. So here you go. Do we have any 0 pairs? No. Therefore, this is negative 3x squared. Are we there so far? I know some of you are still like, what? Squares are rectangles? Check this out. We got tiles. Are we there? Next, distributive property. 3 times negative x squared. What's the coefficient here? 1. So it's a negative 1. So that means we're going to multiply 3 times negative 1x squared. That's negative 3x squared. And the last one, using the area model. You draw your rectangle. Length here is 3, or width, and then the length is negative x squared. And once the coefficient is negative 1, therefore 3 times negative 1x squared, that's negative 3x squared for the area. We got this? All right. So I just wanted to introduce so you can see all the different ways that we can multiply. For right now, we're going to leave the tiles aside. I do want you guys from this point forward to focus on distributive property and area model. So every neighbor what I just said, please. Okay? So with that said, copy these, example C and example D. And we're going to do these together, because I want to see how you do. Okay. I don't know. All right, here we go. Distributive property. We circle the 3, show with an arrow. 3 times 2, that's 6. Circle the x. X times x, that is x squared. Yeah, that's what we're doing. Yeah. Not yet. Not quite. We're getting there. Foil is what they use for lunches. All right, here we go. Draw your rectangle. Here it is. And this side is 3x. This side is 2x. And to find the area, we need to multiply these. So 3 times 2, that's 6. X times x, if you put the 1s there, and just like Sergio said, we add the exponent. So this is x to the second. So far, so good? All right, let's go to the next one. Circle the coefficient. This is negative 8, and we're going to distribute that over here. That becomes negative 40. Circle the next variable, which is x to the first, and we're going to distribute that here. That becomes x to the third. And the area model should be the same, right? So you draw your rectangle. This side is negative 8x. This side is 5x squared. So negative 8 times 5, that's negative 40. And x to the first times x to the second, that's x to the third. And the area is the same as the product. You got this? All right, let's do some practice. Do these next ones by yourself. Example 1a and 1b. We got multiply 6y cubed times 3y to the fifth and 3mn squared times 9m squared n. Go. All right, here he goes. A. Distributive property. 6 times 3, that becomes 18. Y to the third times y to the fifth becomes y to the eighth. Very good. From there, the area model. Look at those rectangles. 6y cubed, 3y to the fifth. This is 18, y to the third, y to the fifth. That's y to the eighth. So far, so good, right? 3 times 9, that's 27. M times m squared, that's m cubed. N squared times n, that's n cubed. And so we got that. Okay, we got this, right? Now, who's noticed so far that we've only been multiplying monomials times monomials? Okay? So for right now, I'm just going to add one more monomial just to crank it up a notch. Here we go. Copy this one. Bam. Example 1C, and it says multiply parentheses 1/4 s squared t squared, close parentheses, open parentheses, st, close parentheses, open parentheses, negative 12 st squared. And we'll do that one together. Yes. And we're not going to, for this one, we're not going to use the area model, but let's just use distributive property. Here we go. So, is there multiplication throughout? Yes. So I'm going to start first with the number only. 1/4, and I need to distribute that, and all the way over here there's the other number, which is negative 12. Is that correct? I'm going to show you the operation so you can see it. 1/4 times negative 12. Negative 12, we can write that as a fraction. So therefore, this is negative 12 over 4, which is what? Negative 3. Okay, so we're done with the numbers. Now we're going to focus with the variables. S squared times S, and then from there times S. Does everybody see that? So S squared times S is S to the third times S. That becomes S to the fourth. Is everybody following? Next, T squared times T, and then times T squared. Because they have the same base, right? So what is T squared times T? T cubed times T squared, that's T to the fifth. Are we doing good? All right. So, let's do some more practice. Do these next ones by yourself. Do these two. Choose any method if you want to use the area model or distributive property. You don't have to use both. Copy that. Here we go. Answer. Example 1D. 1D. Anybody? No? Okay. Because previous years people were like, One Direction. No? Never mind. Okay, here we go. Answer. Who got 18x to the fifth? Okay, and for this one, 10 r squared t to the fourth. You got this, right? Okay, so now let me give you one with 3 monomials. Here we go. Do this one. Boom. Example 1F, we got parentheses 1/3 x squared y, close parentheses, open parentheses, 12x cubed z squared, close parentheses, open parentheses, y to the fourth, z to the fifth. Copy that. See if you can do that one by yourself. Go. All right, let's see. Once again, if you have if your noodle is kind of like short-circuiting, just use your colors so you can stay organized. Numbers with numbers, same bases with same bases. So watch. 1/3 times 12. That became 12 over 3, which is 4. Are we there so far? From there, x squared times x cubed. That became x to the fifth. From there, y times y to the fourth became y to the fifth. From there, we got z to the second times z to the 5th became z to the 7th. Hands if you got that? Okay. And is it in alphabetical order? Yes? Okay. Remember, these, some of you are getting confused doing this. This is not in standard form because it's only a monomial. Standard form is when it's a polynomial. You arrange the different terms. Yes? Sure. Yes. By the letter. All right. So we're done with the easy stuff. Let's crank it up a notch. Yes. So now check this out. Look at this one. Example 2A. The previous ones were only monomials. What do you notice now inside of the parentheses? Which is a what? Okay, but it has a specific name. How many terms inside? It's a trinomial. Okay, so copy this one, please. Example 2A, 4 times 3x squared plus 4x minus 8. We're going to do this one together, but then I'm going to show you the area model using this one. Okay, so here we go. Distributive property. I circle the 4. First arrow to the first terms, 4 times 3x squared, that is 12x squared. Next, 4 times positive 4x becomes what? Plus 16x. 4 times negative 8 becomes negative 32. And we're done. Are we there so far? Okay, now, where I'm going now is with the area model. So pens down, eyes up here. Check this out. I'm going to create an area for this trinomial. Look up, please. Pens, pencils down. Okay, so this measures 4. This measures 3x squared plus 4x minus 8. But if you notice when we started, it was only one whole area, wasn't it? Because it was only a monomial. Is that correct? So let me ask you this. How many monomials are there in a trinomial? Tell your neighbor, please. How many monomials are there in a trinomial? So let's see. If we revisit the definition of polynomials, we said polynomials are monomials or sum or difference of monomials. Is that correct? So that means each term is a monomial. Do you guys see one monomial here, another one here, and another one here? So how many? 3. So to show that they are a monomial, one ends about right there, another one ends about right there, and watch. Look what I just did. If I was to cover this, doesn't that look like what we did at the beginning? You guys see the area just right there? But now we have 3 different areas. So, check this out. 4 times 3x squared becomes 12x squared. 4 times 4x becomes positive 16x. And 4 times negative 8 is negative 32. Copy that, please. All right, we got this, right? So this next one, I want you to do it both ways. Distributive property and area model. Once again, everybody say thank you, Voss. Thank you, Voss. All right, here we go. Copy this one. Example 2B. We got 2 times 4x squared plus x plus 3. Show that using distributive property and area model. Copy that. Go. Answer, we got 8x squared plus 2x plus 6, and you did that distributive and area. Is that correct? All right, so now that we're done with the easy part, let's continue. Who notices right now that the outside factor is only a number? Boom. Copy this one, please. Example 2C. 6PQ times, parentheses, 2p minus q. So now inside of the parentheses, what kind of polynomial is this, everyone? If it has two terms? Binomial. Okay, so now we have a monomial times a binomial. And we're going to do this both ways, distributive property and area model. So here we go. So I'm going to start with blue. I'm going to multiply this one times the first term. Therefore, 6 times 2, 12, p times p, p squared, q times, there's no q here, so basically it just comes down and it slides right in there. Everybody see how that works? Second, same factor outside, now times the second term. What is the coefficient of the second term? 1, so it's a negative 1. Everybody see it? Here we go. 6 times negative 1, that's negative 6. P, there is no p here, so we write the p right there. And q times q becomes q to the second. Can we combine anything else? No. We're done up to right there. Area model. Let's draw a rectangle. Right here is 6pq. Over here it's 2p minus q. And we divide it right here because it's a binomial. Therefore, we got this times this is 12. P times p, p squared q. And then the same 1 times the second term, coefficient is 1, that's negative 6. P, q times q, q squared. So, home plate for tonight. It's found on page what? No, that one's not yours. Yours is the bottom one, sorry. 506, 507. 507, numbers 1 through 23, odds. Have a good one, everyone. Enjoy your home play. See you guys tomorrow.